So now that we've been studying voltage, current, resistance of various items put into a circuit, I want to try to tie in something practical. We all have things that we plug into our home and we get energy bills. We pay for our electricity. So how do we actually determine what we're spending on different appliances? Well, it comes down to power and the power consumption of these appliances. So one thing that I want you to do, and we'll do a little activity as a group as well, is to be aware that any item that gets plugged into your outlets in your home or connected to your power supply in your home is by law, has to have this UL logo and rating for what kind of energy, electrical energy it uses. So every single appliance, you should be able to find some logo that looks something like this. I've got some other ones here zoomed in, but I went through my kitchen and I looked at my stovetop. There's the label. Refrigerator, if you open it up, there's the label. Inside the microwave, when you open it. On the side of my mixer, there's the bottom of my toaster oven. And there's my dishwasher when I open it up. And by law, it needs to be somewhere accessible and visible. You shouldn't have to pull your stove away from the wall to be able to identify it. And this is something you're going to find on anything that's plugged into your circuit. And so I want to figure out, well, let's look at my dishwasher. I want to figure out how much is it costing me every year to run my dishwasher. And so when you look at this label, you have to identify some of the things they're giving you. So the way a dishwasher works, you obviously have a motor that's running, but you have a couple components that come into play. You run a motor, that's running the water, it's pumping water in and out. You also have a heater, right? You're heating the water to do it. You're going to heat and dry some things. So they give you some different information here. They tell you, we haven't gotten into alternating current, but the way our current runs in the U.S., we do alternating current at a certain frequency of 60 hertz. That's not so important here, but what is important is, well, this plugs into our regular power supply of 120 volts. In the U.S., the standard is 110 to 120 volts. If you go over to other countries, you might get a little bit more. There are higher voltage lines in your home for bigger appliances, but you can plug in your dishwasher into an outlet. Normally it's wired directly to it, not via a plug. But it tells you amps as well. The motor itself is 2.7 amps, but they give you this total amps. So just by looking at the label, I can identify, well, I know I'm plugged into my home, so I have a 120 volt supply, and amps is current, right? So I know that I'm getting 9.6 total amps of current when my dishwasher is running, right? And so that's probably when it's, doing its full heating cycle. It might not always draw that, but let's just use that large value to go from here. So with those two numbers, we know that power consumption is equal to current times voltage. So we can actually calculate the power, right? So that's going to be our first step, is we're going to calculate the power consumption of this device. And we use P equals IV, which in this case I have 9.6 amps times the 120 volt supply. And when I multiply those, 9.6 times 120, I've got 1152 watts. All right, so that's our power consumption for our dishwasher. Now, a watt is joules per second. And so we know that the energy we use is a function of how long we run and consume that power. So the next thing we need to figure out is, well, how much is my dishwasher running? All right, so step 2 is we need to determine the time the dishwasher is running. Well, that's going to vary depending on your household. My household now with 2 kids and a wife, we run it pretty much every other day. All right, so let's say, of a 365 day year, right? If I cut that in half, what is that? About 180 days, right? And so I'm running it once a day for 180 days, and let's say it takes an hour to run. I'm not sure the exact time, but roughly an hour, maybe as much as an hour and a half, right? So this is let's say it's 1 hour per day times 180 days in a year, right? So if I'm looking for a full year, right, I'm basically getting 180 hours of usage on this appliance, right? And so if we know how much time it's running, I've now determined the number of hours that this thing runs in a calendar year. So it's an estimate. It doesn't have to be exact, but trying to get a ballpark here. Well, if I know the time and I know the power consumption, we can calculate the energy. And the energy is what we purchase. Energy is in joules, but there's another unit which is the same as still an energy unit. It's a power times a time, right? If we remember, energy is just equal to power times time. Remember, power is energy over time. And so I actually know those things. Now, usually we measure energy on our energy bill, not in joules, but in a unit called a kilowatt hour. Kilowatts times hour. Kilowatt is power, hour is time. Well, look at our units right here. We already have hours. We have watts. So let's get that to kilowatts. And that's just dividing by 1,000. I have 1.152 kilowatts is the power consumption. And so the energy for my washer dryer is going to be the power, 1.152 kilowatts, times the time it's running, 180 hours. And we get a unit called a kilowatt hour. So if I divide that by 1,000 and then multiply by 180, this thing uses up 207.4 kilowatt hours of energy every year. So what does that actually mean, dollars and cents? Well, depending on where you're located and where you're getting your energy, the cost of 1 kilowatt hour is actually not that much. It might only be like 15 cents, right? And so if I'm consuming 207 kilowatt hours, well, if I want to know how much I'm spending on my dishwasher to run it, I'm going to take the 207.4 kilowatt hours, and I'm going to multiply it by the cost of 15 cents for every kilowatt hour. Notice how the units cancel, and I'm left in dollars. So if I take this number, the 207, and I multiply it by 15 cents per kilowatt hour, I spend $31.10 on my dishwasher every year just to run it. All right, so you get a sense of a cost analysis here for one appliance in my home. All right, and if I divide that by 12, I get the cost to run it, over 1 month, and then I can take it down and figure out. In fact, if I divide it by 180, I actually will figure out exactly how much it costs me to run one cycle. Right, it costs me about 18 cents, 17 cents to run one cycle of dishes. It's actually not that crazy. But we can actually do this kind of cost analysis for everything in our home, and we'd follow a similar process. So just to kind of show you some of the things you're going to see, sometimes the labels don't give you current and voltage. If I look at my different appliances, there's my dishwasher's label, right? We saw that. Well, here's my toaster oven right here. Well, I have, hey, they tell me watts right here, 1,200 watts, right? Well, what was my toaster oven or my dishwasher? My dishwasher was 1,100 watts. So my toaster oven and my dishwasher are about the same power consumption. Now, I might not be running my toaster oven as much, right? Maybe 5 minutes a day if I have toast every day, maybe 5 minutes a week if I do it once a week, right? So you can figure it's not going to cost me that much to run that one, right? Look at my KitchenAid mixer. This one's label just tells me the watts as well, a lot less, only 325 watts. I might use that once a month, so not a very expensive appliance to have. Your microwave, you have an input, they tell you the wattage in input, and then the output is kind of the energy that's going into the food itself. but I would use that rated input value is what you're going to be spending. Well, how often do you use your microwave? And again, it's got different settings to where you might not be running it full blast, so you can make some estimates there. Here's my refrigerator. Here, this is our refrigerant, right? R134A. We have 5 ounces of it in there. But notice here, they use 7.1 amps at that 115 volts, right? So again, it's always 110 to 120, but you can actually, there's our current and our voltage. You can multiply them to get the total wattage of my refrigerator. And if you go all the way up, you got your oven and your stove top. Now this one gives you values in kilowatts. So I've got an electric range. So I have 2 numbers here. I'm not actually certain exactly what this is. Now this one indicates it's off 120 volts. This one's off 240. My range might actually be plugged into a 240 volt supply from my home, in which case it might actually consume more power. I'm not actually sure exactly how this rating works, but either way, I'll pick one of these numbers, 8.5 kilowatts compared to the 1.2 of my dishwasher. So a lot more energy to run this stove. And that's because these electric stoves are literally just one metal wire that is just running electricity straight through it with very low resistance to be able to heat the food and get things hot. So you end up spending a lot of money on that oven, and if I did the analysis, I'm sure I'm spending a lot more than that $31 to run my oven, considering I use that stovetop pretty much every single day for an extended period of time. So hopefully you get a sense of what some of the things we can do here to start to analyze what things are costing us in our home.